So we're going to revisit the concept of area between curves again, but today we're going to be talking about integrating with respect to y. So we'll talk about when you do that, okay, and how to do that, okay. So if I asked you guys to find the area that didn't come out right. To find the area from the function to the x-axis. In other words, this area here. Well, first of all, it's just a triangle. So you guys would probably just do it using geometry, and that's fine. But how do we do it using calculus? Well, we would do an integral. We would take the function, which is negative 1/2 x plus 3. We would integrate that with respect to x. So there's a dx there. And what numbers would go here and here? Well, it would be the one on the left is 0, and the limit on the right is 6, right? So there's nothing new there. That's old. But I want to show you guys something a little different. All right, but what if I asked you a different question? Find the area to the y-axis. Okay, so finding the area between your function and the y-axis. Well, it's the same shape, you guys, so it's going to be the same answer. And therefore, you could really just do the same thing. But there are some functions where you wouldn't be able to do the same thing, so you'd have to do something different. I want to show you another way we can find the area, especially if they ask you to find the area to the y-axis instead of the x-axis. Since we're doing it to the y-axis, we're going to do everything in terms of y instead of x. So one difference that makes is I have to change my equation. Instead of having the y by itself, I want to get the x by itself. So I'm going to move 3 over first. Next, I would multiply everything by a negative 2. And now I've got that function. And that's the function I would be integrating with respect to y instead of with respect to x. So I'm going to put a little dy here. So that's one difference. Is that the equation, if you're doing dy, then the equation that you put in here has to have a y in it, not an x. So I had to rewrite my equation. It's the same equation, I just rewrote it, okay? But here's another difference. Whenever we do dx, the limits are x values. But we're doing dy. So what do you guys think the limits would be here? 0 to 3. We would start here, and we would stop here. We're going from bottom to top. So that would be 0 and 3. And just so you know, whether you integrate from 0 and work your way up to 3 like that by finding the area to the y-axis, or if you start at 0 and work your way up to 6 by going to the x-axis, for this particular example I'm giving you, it's the same shape, so you're going to get the same answer. They're all going to give you the same area. But there's other questions where that wouldn't be the case. Like, for instance, if I gave you guys this. Well, if you did a dx problem, maybe you could find this area to the x-axis, right, underneath of that curve there. But if you wanted to find what's the area to the y-axis, if you want to find this one, well, now they're different. So in that case, you would want to have it rewritten here as in terms of y, because we want to go to the y-axis, not the x-axis. So there's that, okay? So we're going to be talking about integration with respect to y today. We'll talk about when to do that and how to do that, okay? Now, you guys might recall a little while ago we talked about how to find the area between two curves. Okay? And don't write this down now, but I'll just remind you. When you want to find the area between two curves, what we talked about was you put the first intersection point, which is on the left side there, and you put the second intersection point, which is on the right side there, and then you do top minus bottom, right? Well, whenever you're doing things with respect to y, stuff gets reversed instead. Okay, so once again, instead of looking at your left x point and your right x point, you're looking at your bottom y value and your top y value. So look at the picture. C is the bottom y value. D is the top y value. So you go from bottom to top here. Okay? Bottom y, top y. Those are your limits. And also, instead of doing top function minus bottom function, look at those graphs. You can't really say one's on top and one's on bottom, right? It's more like right and left, isn't it? So in this case, it's the right function minus the left function. Right is bigger than left in math, so we do right minus left. But other than that, it's the same. Okay? So instead of left x and right x for the limits, we have bottom y and top y. And instead of top function minus bottom function, we have right function minus left function. This just gets reversed because we're switching the variables, basically. Okay? So there's the idea. That's how you can find the area between two functions with respect to y. Okay? Now, we're going to look at a few examples today, but let's answer the question first. Why would you ever want to do that? Okay, in what cases is it helpful to integrate with respect to y instead of with respect to x? Well, if you did the extra credit, I think you saw one like this, but we also did one in class like that before we left, but you might have forgot because that was about a week ago. But to find this area, you actually have to break it up into two integrals if you want to do it with respect to x. First of all, you'd have to go from 0 to a using this function first, which is the f function. So that would give you the area under the f function. And then you would have to go from a to c. Oops. From a to c for the other function, which is g. And after that, you just add these two things together, and you've got the total area. Okay? But actually, it turns out that this might actually be a little bit easier if you do it with respect to y. Okay? Let me show you why that is. This k is a little bit off. I meant that to be like right about here, just so you guys know, because that's where they're crossing. But anyway, if I'm doing this with respect to y, then what's my bottom y value for this area? What's the bottom y value? 0. What's the top y value? Yeah, it's k. And then we do, not top minus bottom, we do right function minus left function. The right function is g of y. The left function is f of y. So if you do it with respect to y, it's actually only one integral instead of two. So that's one benefit. It might be faster, especially if you had to do it by hand. This you'd have to do two separate integrals. Over here, you could just do one. Okay? So that's one reason why. What's another reason why we might want to integrate with respect to y? Well, I've already mentioned this one. What if they ask you to find the area to the y-axis instead of the x-axis? So in that case, you're going to need to integrate with respect to y. Okay. Finally, they just might give you the equations that way. If they give you an equation like this, well, maybe it's a dx problem. But if they're giving it to you like this, chances are they're expecting you to do things with respect to y. So we have three situations that I'm sharing with you where it's kind of nice to do dy. Sometimes it just makes the problem maybe a little bit easier. Sometimes you have to because they want you to go to the y-axis. Sometimes that's how they give you the equation, so you might as well just do that anyway. So that's when you might want to integrate with respect to y. And so for the rest of the class now, we're just going to practice doing that, okay? So let's begin. Now notice this. Write but do not evaluate an integral expression that gives the area bounded by the curves and Well, notice how they wrote the equations, right? So that when they write the equations like that, x equals and then an equation with y in it, we're dealing with a dy problem. So we're doing things with respect to y. All right, so I'll just draw a little arrow there, and that means dy, right? Now, what's our first step when we're doing these? The first step is to find where they intersect. This is review. Hopefully this is not new to you guys. The steps for doing this is the same as all the other steps. We're doing things with respect to y instead of x. So the first step is to find where those two functions intersect. How do you do that? You set them equal to each other. So we're going to say y plus 1 is equal to 1/2 y squared minus 3. Now I'm noticing that this is a square, and when we have quadratics, you want to move everything to one side so it equals 0. So I'm going to minus 1 on both sides, and I'm also going to minus the y on both sides. That way I get 0. I'm going to put the terms in order from greatest to least. Not real fond of the fraction in the front there, so we can get rid of that. If I just multiply everything by 2, 0 times 2 is still 0. 2 times 1/2 is 1. 2 times a -1 is -2. And 2 times 4 is 8. So now that's a little bit more doable. We're ready to solve that. That's a trinomial, so we'll try factoring first. And it does factor. It would be y minus 4 and y minus 2. No, y minus 4 and y plus 2. We're going to set each one equal to 0 and solve. So there's one intersection point, so they intersect at y equals 4. They also intersect at y equals -2. We also need to figure out, now usually before, when we did this before, we had to figure out which one was on top and which one's on bottom. But now we need to figure out which one's on the right and which one's on the left. But you do it the same way. The way that you do that is you pick a point between your intersection points, so between 4 and -2. So I'm going to go with 0. And you're going to plug it into each function. We'll plug it into y plus 1, and we'll plug it into 1/2 y squared minus 3. So we'll plug in 0. That's 1. That's -3. This one's bigger, which means that this is the right function, and that's the left function. And at that point, we're pretty good to go ahead and set it up. What's my bottom y value where they intersect? Well, that would be the lowest y value where they intersect, which is -2. The upper y value where they intersect is 4. The function that's on the right is the y plus 1 minus the function on the left, which is 1/2 y squared minus 3. And this is all with respect to y. Okay. Why was it with respect to y? Because that's how they gave us the equations in the beginning anyway. Okay. Now you guys have a picture on your paper. I don't have it displayed up here, but another way you could tell this is a dy problem is from the picture. We don't really have a top function and a bottom function, do we? I mean, look at those graphs. It's not like one of them's on top and the other one's on bottom, but it is like one's on the right and one's on the left. So that's another way you could tell you're doing a dy problem. Okay. Let's go ahead and throw in at y'all though. So here's one for you guys. So go ahead and do that. We're just setting it up. We're not going to actually find the integrals today. Once again, on your homework, I do want you to do that unless it says write but do not evaluate. But if it doesn't say that, I do want you to work it out. And remember, also, only use a calculator if it tells you to use a calculator. But I'll let you guys work on this for a little bit. So step one is to set these things equal to each other. Now, I'm not going to show all my work for that, but if you go ahead and solve it, you guys should have ended up getting 6 and -2. Okay, so those are going to be your lower limits and upper limits. Then we need to figure out which one is on the right and which one is on the left. We do right minus left. So you would pick any number that's between -2 and 6. Once again, 0 works pretty good. Plug it in. It turns out this one equals 1. This one equals 4. So this is the bigger one. So that means that's the function that's on the right. And we would have, this is our final answer. Once again, now if this was homework, I would probably be expecting you guys to go ahead and work that out from there, because it doesn't say write but do not evaluate, so just find the area. So I do want you to go ahead and do that. If it says no calculator, don't use a calculator. If it says calculator, use a calculator. If I don't tell you what, then just do whatever you want, which is probably calculator. But, so there's our answer though for that. Now, when you're using a graphing calculator and you're doing integrals with respect to y, there's some things you want to keep in mind a little bit. Let's say we wanted to find this answer on our graphing calculator. Okay. Well, when you type it into your graphing calculator, it's going to look like this, because they don't do y's, they do x's. Okay, so you'd have to be typing in x's, which means you're treating all the y's like they're x's and all the x's like they're y's. And that actually can make things a little confusing too when you're looking at graphs. So like the graph of these two functions here, the y plus 1, that's the straight line here, and the 1/2 y squared minus 3, that's this guy. So there's our right minus left. And they cross at these 2 points here, -2 and 4. Notice that those are y values, right? As they should be. But whenever you graph this on a graphing calculator, you're going to be graphing them as x functions, not as y functions. So it looks like that. Do you notice it's like basically it's the same shape, it's just flipped? And that's just because you're treating the y-axis like the x-axis and the x-axis like the y-axis. It gives you the same shape, it's just flipped. But that you're going to have to be aware of a few things. Whatever function is on top, that's kind of like the one that's on the right over here. And whichever one is on the bottom, that's the one that would be on the left for the other one. Another thing to keep in mind is that when you find their intersection points, that intersection point and that intersection point, even though they look like x's because of the way we've graphed it, really remember those are y values. Okay, so that's something to keep in mind. So when you're doing a graphing calculator, it's almost like exactly what we did before, but really we are doing something different. So just got to keep that kind of stuff in mind. So let's say I gave you guys this one here, and we had to do it on a graphing calculator. Let's take a look at it. And that's actually the same exact one that we had back here, isn't it? So I don't think there's going to be much benefit in us working this one out, but there it is. So just keep in mind that when you're doing things with respect to y, like let's say that you have you're taking your AP test, right? and they give you this problem. But it's a calculator question, so you type these functions in your calculator. Well, when you type it in, don't be surprised when your graph doesn't look like that. It looks more like this one over here. Okay, so don't be surprised, but just be aware that because you're treating the y's like x's, it will look a little different. All right, I'm going to skip that though. Let's go to example 3. Now, before we even begin, I want you guys to find the place where these functions are intersecting. So go ahead and do that. And when you do it, by the way, I want you guys to don't write down just the x value, write down the whole point where they intersect. Because when you do it, it does tell you the x and the y. So write down the 2 points where those lines are intersecting. I'll give you guys a little bit of time to find those, and I'll ask you what you got. So go ahead. Now, I just wanted to do that up front to get that out of the way, review how to find points. You're going to have to do it anyway. But let's actually look at the question now. The question's interesting. This is a 2-part question. It says, write but do not evaluate 2 integral expressions, one with respect to x and another with respect to y. So we're going to have 2 different integrals. One is going to be with respect to x. The other one's going to be with respect to y. And we're going to find the area. And these are just, why are we doing this? Well, they would give you the same answer, just so you know. It's just that I want you guys to know how to do both strategies and getting these ideas in your mind. I actually have seen some multiple choice questions where they'll say, which one of these options is not a way to find the area? And they'll have one of them as the dy way, one of them as the dx way, and they'll have some third one that doesn't matter. You have to find the one that doesn't work, right? So you do want to know how to do both. So now I'm going to show you guys a really neat little template that'll be helpful for you in your notes. When you're trying to do something with respect to x, here's how it's going to look. You're going to have the left x value goes here, and up here, the right x value goes there, and you're going to do top function minus bottom function. Oops. When you're doing it with respect to y, you're going to do the bottom y value. Maybe I should put the y underneath so it doesn't look like it says bottom. And then you're going to do the top y value. And it's going to be the right function minus the left function. There's a little thing we got to be careful with also with that one, but we'll cross that path when we get there. All right, so with respect to x, it's going to follow this template, and with respect to y, it's going to follow that template. So let's go ahead and fill it in. What is my left x value of intersection? Let me call on somebody. Mariah, what's the left intersection point for x? Yep. Eric, what's going to go up here? So let me help you out a little bit. The right x value goes there. So find the right intersection point. What's the x value there? I maybe you said it and I just didn't hear you right. But what do you? Yeah, 3.1. Sorry if that's what you said. But yeah, there it is. All right. Now we're going to do Jacob. What function comes first here? Which one? Good. Because it's top minus bottom. Ln is the blue one. You could tell because it's curving. And that one's on top. So that one has to go first. Which means that x minus 2 is the red one. It's on the bottom, so it comes last. Parentheses are important, you guys, by the way, because we're subtracting this, which means that negative actually goes to both terms. So you want to put parentheses around these. All right, so there's, I'm not going to solve the problem, but there it is. There's your how you would find the integral or the area between those two curves with respect to x. Now we're going to do it with respect to y. So let's see if you guys can figure this one out here. Elena, what will I put down here if I'm integrating with respect to y? Yes. So for this one, you do the bottom y value, which is negative 1.841. Asnith, what will the upper limit be? Yep, 1.146. Now the next part is a little bit tricky. So I'm going to ask somebody, and if they get it wrong, it's okay, because it's tricky. I'm going to ask Jazir. What goes here? ln of x? Why? Okay. So it's right function minus left function. Which line's on the right side? The red one or the blue one? The red one. Now, you might be tempted to do this. But don't write this. That is the one that's on the right, and this is the one that's on the left. But can someone tell me why that's not correct right now? It's got x's. I need these to be y functions, not x functions. Right? So I need to fix that. Get rid of that. Here we go. So I'm going to take my my x function here, and I want to get the x by itself instead. So I'm going to add 2 on both sides. And there it is. That's what I'm going to put here. We do the same thing for the ln. I know the ln function goes here, but I can't leave it as ln of x. It's got to be the one with the y by itself. So here's my ln of x equation. How do I get the x by itself? Well, we cancel out ln's with e. So instead of putting ln of x there, I'm actually going to put e to the y there. So those are your two integrals. Now, I'm not going to have you do this right now, but you could punch both of these problems into your calculator. They'll both give you the same exact answer because both of them are finding the same area. I just found that area in 2 different ways. One way is with respect to x, one way is with respect to y. Okay, so that's that. So I have one problem I want you guys to do. It's not, I didn't print it for you because I didn't want to waste a whole other page on just one slide, but it will be up here. So now before you guys start it, let me give you guys a little helpful hint. You need to be able to know which piece goes with which line. So let's start with this one. Do you guys see which one that is on the graph over there? That curving one, right? You guys see which one that is? Right there, right? Y-axis. See how you do this one? It's, if you stick to the template I gave you, remember those little 2 integrals I gave you? I told you top and bottom, left x, right x, and stuff like that. Stick with those. I think you'll be okay. What's funny about this is that this is different because I've got 3 lines up here. The one I just gave you only had 2. Now, don't overthink it. Just use the templates that I gave you, and I think that will be helpful for you. But I'll let you guys ponder it. Give you for the dx one, we do the left x value and the right x value, and we do the top function minus the bottom function. The top one is the purple, that's 4. The bottom one is the green, that is the square root of x. So there's your dx area. The dy one, we do the bottom y value, the lowest y value, to the highest y value, which is 4. And you do right minus left. Now, which function is on the right? What color? Green is. So that would be the square root of x. But I'm going to fix that in a minute because that actually doesn't go there. Minus, what's the right function? What function's on the right? Oh, I'm sorry, left, yeah. The red one, right, which is 0. Now, this doesn't actually go here, though, right? Because when you're doing dy, you can't have that. You have to get the x by itself. So what goes there is y squared. Now, just so you guys know, on a multiple choice test, they probably wouldn't include the 0 there. They would probably just have this, just so you know. Okay? There's no point in putting minus 0 there. But there it is. Also, don't be surprised if on a test they might not tell you that the equation of that line. They might just say y-axis. So you have to know that means x equals 0. We'll see you guys tomorrow. Have a great day.